Hey everybody, so I'm pretty tired, but the grind shouldn't stop. The tea stays green and the lines keep roaring. I think a YouTuber back in the day used to use this phrase. But we have to keep on doing the questions because your exam is in a few days, and I've shared the worksheet with you in the white background. It's going to be in the description, uploaded on the drive. I've also sent it in all the groups. So you guys can check it out, download it, try to do it on your own, and then refer to this video solution, right? And yeah, keep on having a positive outlook towards life, keep on persevering, just a few days left, and keep on sharing resources with each other, videos with each other, materials with each other, and obviously God is going to compensate you for all the good that you're doing, right? So don't be selfish in this point at this point in time, okay? So without further ado, let's just look into this question. It says information about some silver compounds is shown. He's given us the formulas and he's given us the solubilities. And what you realize is even if he hadn't given us the solubilities, we would know that all carbonates are insoluble except for group 1s and ammonium carbonate. Since it's neither, it's going to be insoluble. All chlorides are soluble except for LMS, lead, mercury, and silver. And in our course, we only have silver. So silver chloride, insoluble, white precipitate, right? And all nitrates are soluble, so obviously soluble. All oxides, we don't know about the solubility of oxides in our course, and we don't have to know it, but he's given it to us that this particular oxide is insoluble, right? So we don't need to know the general rules for it. Now it says which equation shows a reaction which cannot be used to make this silver salt. Obviously these three salts are insoluble, right? So if these three salts are insoluble, we are going to use a precipitation reaction to form them. In this particular case, if you look at option number A, it's pretty evident that it's a correct way. Why? Because you're having two aqueous solutions, right, of this particular compound right here. No, not this compound, this particular compound, silver chloride right here. So when you add these aqueous solutions together, so you have a silver nitrate aqueous, which means you have the silver ions and the nitrate ions, and you have hydrochloric acid, so you have the H plus ions and the chloride ions. And what you realize is all these ions are going to come into contact with each other, and when the silver ion comes into contact with the chloride ion, they're going to precipitate together to give you a white solid, and HNO3 is going to be left back in this solution as aqueous, right? So that's the correct equation, that's the correct reaction of making this silver chloride, right? That's why A is wrong, because he's saying which of these reactions is not correct, right? Now if you look at B out, B says that you have silver oxide and you are reacting it with HNO3, and you're going to get silver nitrate and H2O. Absolutely correct equation. Why? Because silver oxide is basic in nature and this is your acid. So an acid base reaction is going to take place. Silver is going to bond with this nitrate to form silver nitrate, and the hydrogens and this oxygen are going to form H2O. So this is obviously a correct equation. Similarly, if you look at silver carbonate, it's a metal carbonate, and when a metal carbonate reacts with an acid, it's going to form salt, which is going to be obviously silver nitrate. The hydrogen in the acid and the oxygen in the carbonate is going to give you H2O, and the carbon and the oxygens in the carbonate are going to give you carbon dioxide. So that's obviously a correct way of making it, right? Done. And then he's given you silver reacting with HCl. Sir, this is a wrong reaction. Why? Because silver cannot react with hydrochloric acid. What's the reason? It's the same reason why copper cannot react with hydrochloric acid. And the reason is that hydrogen is above silver, copper, and gold in the reactivity series, right? So that is the reason why this silver cannot displace this hydrogen from the acid. Therefore, D is the incorrect method shown, right? So he's also asking you which one of these is not correct. Done. So D is the correct option. Now this particular MCQ says how many species are acting as bases in this reversible reaction. I've seen this question so many times in the group session, in the discussion forum, and what you need to realize is it's no longer a part of your course, right? The concept of conjugate acid, conjugate base is not in your course, but what we can do is I can teach it to you to some extent if you want to know, but this is no longer in your course. So what happens is that we know, according to Bronsted-Lowry, that an acid is a proton donor and a base is a proton acceptor, right? And what has happened here is that HNO3 is basically the acid because it's donating the proton to give you the nitrate ion, and once it donates a proton, the H2O goes into H3O plus, right? And you could think about it like this. So if H plus is being donated right here, there's an addition of one hydrogen, so you're going to add H3, and because there's the plus, you put a plus all over it, right? That's just a trick towards it. We know that it's dative bonding in A levels, who cares? But so we realize that H2O is basically acting as a base in this particular case. So this is true, we have one base. But if you look at the right hand side, now this H3O plus has one extra hydrogen ion, and this nitrate is already there, and it's a reversible reaction, which means it can go in the backwards direction. And if it were to go in the backwards direction, what would happen is this H3O plus would donate a proton to this nitrate ion, and obviously only then would you form H2O and HNO3, right? So because nitrate is accepting a proton here, we call this the conjugate base, right? So it's still a base, and we call this particular as a base. So nitrate is acting as a base, and here H2O is acting as a base because they're both accepting protons. Therefore B should be the correct option, but this is no longer in your course. Now it says propene reacts with bromine in an addition reaction. So obviously we've done these MCQs a gazillion times. So if I make propene for you, meth propene, because why am I making a double bond? Because it's an alkene, it ends with an ene, therefore there should be a carbon-carbon double bond. It's unsaturated, right? And let's make the hydrogens. So hydrogen, 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 done. And it's reacting with Br2 in an addition reaction. So what's going to happen? We know that the double bond breaks, and once this double bond is going to break, the new atoms are going to bond wherever this double bond breaks. So it's between the first and second carbon. So the double bond, when it breaks, the new atoms are going to be bonded on the first carbon and on the second carbon. Remember, the orientation of bonding does not matter as long as they are bonded on the first and second carbon where the double bond is breaking, right? So if I show you the products, what's going to happen is this double bond broke, right? And the new valencies are created right here. So this carbon has now made 3 bonds, this carbon has now made 3 bonds. So the bromine atoms, one is going to bond on this carbon and the other one is going to bond on this carbon. So if you check this out, which is the correct option? The correct option is C. Why is B wrong? Because he has bonded both the bromine atoms on the same carbon, which is not the case. Each carbon is going to be having one extra valency, right? Which means that each carbon will be able to accommodate a bromine atom, because then once this double bond breaks, you only can make 3 bonds. You only have made 3 bonds. It can't be possible that both the bromine atoms are on the same carbon, right? Similar is the case with A. If you check A out, he's only added 1 bromine atom. So here he's not shown as an addition reaction, it's effectively shown a substitution reaction. And D is wrong because the new atoms are bonded on different carbons, not on the carbons where the double bond had broken, but one is added here and the other one is added here, which is not the case. We know that the new atoms are going to bond wherever this double bond. So if the double bond had broken here, one Br should have come here and the other should have come here. If the double bond had broken here, one Br should come here and the other should come here, right? So D is also wrong. Moving on, it says acidified aqueous silver nitrate. Acidified means that he's added dilute nitric acid to it, right? So dilute HNO3 is added followed by silver nitrate. That's what acidified nitric acid means, right? It means it already contains the acid. Now it says is added to a test tube containing aqueous chloride, and we know that this particular test is of halide ions. So we use this test in order to confirm whether there are any halide ions present or not, right? So you have the chloride ions in the solution and you're adding the silver ions and the nitrate ions, and what's going to happen is we know that silver chloride is insoluble. So the silver ion, when it comes into contact with the chloride ion, they're going to form a precipitate, and obviously the precipitate is going to be of silver chloride, and it's a white precipitate, right? Silver chloride is white PPT, you don't write PPT in your paper. Well, now you no longer have a theory paper, you're already done with it, but you write the whole word precipitate, right? So it's gonna be white precipitate, silver bromide is cream precipitate, and silver iodide is a yellow precipitate. So therefore A and B are wrong, because a yellow precipitate forms when you have the iodine ions, not the chloride ions. And between C and D, if you check this out, it says observation after leaving it in the sunlight. Now this particular bit is removed from your course, but what you need to understand is, even if you were doing trial and error method or elimination method, you know that why would this precipitate dissolve, right? We know the fact that, you know, an insoluble precipitate does not dissolve. Why would it dissolve when you leave it in the sunlight? So C can be eliminated, and therefore D would be the correct option. It says precipitate turns gray, and the reason dissolves mean कि मतलब sunlight say, you know, it is soluble somewhere. No, what happens is basically the silver chloride solid that you have, it goes, when you expose it to sunlight, it gives you silver solid, and it gives you the chlorine gas, right? So it's basically decomposed, and silver is obviously gray. So that is why the precipitate turns gray, because you go from silver chloride to silver and chlorine gas, right? And why does this happen? Because the silver ions are reduced. Obviously, here silver had the oxidation state of +1, and here it's 0. So you went from +1 to 0, therefore that's reduction. But this particular bit, again, is no longer going to be tested in your course. Done? But again, trial and error. Reactions of 3 metals and their oxides are shown, okay? And 1, 2, 3, and he's saying what is the order of reactivity of these metals from the most reactive to the least reactive. Now, pretty easy. If you check metal 1 out, it can, when you add it to dilute hydrochloric acid, it reacts with it, right? So it's obviously above hydrogen in the reactivity series. If you check 2 out, when you add it to dilute hydrochloric acid, it reacts with it, which means that, you know, it is above hydrogen in the reactivity series. And if you check 3 out, when you add dilute hydrochloric acid to it, it doesn't even react, which means it's below hydrogen in the reactivity series. Therefore, B and D could automatically be eliminated, because we know that 3 is the least reactive. Now, if you want to check between 1 and 2 out, it says heat metal oxide with carbon. Sir, if 1 can react with carbon, that means that carbon is able to reduce it. Remember when we were doing blast furnace, the reason why you could, you know, extract iron out of hematite through blast furnace was because iron was below carbon in the reactivity series, right? So it could be reduced by it. So if it is reacting with carbon, that means it's below carbon. And if 2 isn't reacting with carbon, that means it's above carbon. The carbon is not able to reduce it because it's obviously above in the reactivity series. Therefore 2 should be the most reactive, and 1 should obviously be on the second number, and 3 should be at the end. Therefore C is the correct option and A is wrong, because A is saying that 1 is more reactive, which is not the case, right? So this particular MCQ says, when a hydrogen oxygen fuel cell is in operation, a different reaction happens at each electrode. Now, you don't need to know about the reactions that take place. You just need to know about the overall reaction, which is hydrogen reacts with oxygen to give you H2O, and obviously it generates electricity, right? But I've explained it in my live classes how the hydrogen fuel cell works. Again, not in your course. It bamboozles a lot of students when I go into the in-depth explanation, but who cares? Now, it says at the hydrogen electrode, what happens is the hydrogen goes into the H plus ions and, you know, gives off 2 electrons. And that's basically oxidation, because there's a loss of electrons. And remember guys, the electrode at which oxidation takes place is always going to be the anode. And the electrode at which reduction takes place is obviously going to be the cathode. So in this case, if you would compare it to electrolysis, it's the opposite of that. So whenever you're performing electrolysis, the anode is going to be the the anode is going to be the positive terminal, the positive electrode, the electrode attached to the positive terminal, and the cathode is going to be the electrode attached to the negative terminal, or the negative electrode, right? And we know the acronym for that, which is panic. But whenever you're making electricity, it's the opposite, because the actual definition of an anode and of a cathode is that an anode is the electrode at which oxidation is going to take place. Done. So the hydrogen electrode is the anode because oxidation is taking place. Why is oxidation taking place? Because there's a loss of electrons. Done. And here because there is a gain of electrons, obviously reduction is taking place, right? So that's therefore the cathode. Now it says the electrons that are lost at the hydrogen electrode travel through the external circuit to the oxygen electrode, where they are gained by the oxygen and water. Okay, great. And what you need to notice is that 2 electrons are lost, but 4 electrons are gained. So that's not possible. 2 electrons are being lost and 4 are being gained. That's so absurd. Do lose or char gain. So what you realize is that you need to make the electrons equal on both hand sides. And that's why I'm going to multiply this entire equation with 2. Remember how to write full equations from half equations. So it's actually 2 hydrogens going together to give you 4 H plus ions, and 4 electrons are lost, and only then can these 4 electrons travel and be gained by the oxygen and water. So remember this, whenever the electrons aren't equal, you need to make them equal in order to take the combined effect. None? So it's saying a hydrogen oxygen fuel cell is operated for a period of time and 4 moles of oxygen molecules are consumed, right? So 4 moles. So this is 1 mole of oxygen, and he's saying that 4 moles of oxygen are going to be consumed. So this reaction is going to take place 4 times, right? It says which mass of hydrogen is consumed. What is the mass of hydrogen being consumed? Pretty easy to do this. Now, you guys might think, oh my god, this is so difficult, but what you need to realize is if this reaction takes place 4 times, this particular reaction should take place how many times? 4 times as well, right? So you had 2 hydrogens, and if you do, hey, 2 times 4, if 2 moles of hydrogens are here and they're gonna go into the H plus ions 4 times, so how many total hydrogens are gonna go into the H plus ion? 4 times 2, that's gonna be 8 hydrogens, right? So in total 8 hydrogens are gonna go into the H plus ion. And now you can calculate the mass. You know that 1 mole of hydrogen has how many grams? 2 grams in it. So if you have 8 moles of hydrogen, how many grams would there be? X cross multiply 8 times 6, 2 is going to be 16. So how do you know that 1 mole is obviously going to have 2 grams? Well, that's the molar mass. Or you could go into the periodic table and calculate it that, hey, hydrogen is 1, and if you have 2 hydrogens, that's going to be 2. And if you want to do it from the from the formulas, you can say, hey, mass equals mole times mr, which is wrong. It's mole times molar mass, but who cares? So you are given moles, which are 8, and mr of hydrogen is 2. So you could do it from the formula as well, which is going to be 16. So D is the correct option. Remember this, the tricky part here was to understand that he's already told you that the electrons that are lost at the hydrogen electrode travel through. So how is it possible that there are 2 electrons being lost and 4 electrons are being gained? That's absurd, right? So in total 4 should be lost, and therefore then and only then 4 electrons would have been gained. Done? So D is the correct option. Ethane reacts with chlorine in the presence of ultraviolet light, and we already know that it's a substitution reaction. And it says which substances are produced in this reaction. Check it out. So it's meth, that's ethane. And when it reacts with chlorine in the presence of ultraviolet light, what's going to happen is a hydrogen is going to be substituted by a chlorine atom, and the hydrogen that is substituted reacts with the chlorine atom to give HCl. So, that's going to form. This is the new bond forming, that's the chlorine atom, and then HCl. And remember, this is a chain reaction, right? So it can go on and on and on and on and on until all the hydrogens are substituted. So this particular reaction, this particular compound right here, this particular product right here, can further react with chlorine to obviously substitute another hydrogen atom, and the hydrogen that is substituted is going to react with this chlorine atom right here to give you HCl. So remember, this can go on and on and on. So you can have as many chlorine atoms on ethane, and then obviously it's no longer ethane, it's haloethane, but who cares? So that's the chlorine atom that was already there, and another hydrogen has been substituted. So this can go on and on. That's why if you ask about the products that are being produced, one is wrong because hydrogen isn't being produced, dude. And this is a common misconception that students think that, hey, both the chlorine atoms are going to substitute two hydrogens at the same time. It never happens at the same time, and you're going to get the explanation to it later on in your A levels why it does not happen at the same time. For O levels, you just need to know it can never happen in the same time. One will be substituted at one time, right? So you're going to get this chloroethane and then dichloroethane and trichloroethane, and hydrogen chloride is going to form. So hydrogen chloride forms, chloroethane forms, and again 2 chlorine can also come here, 3 chlorines can also come here, 4 can also come here, 5 can also come here. So in total, if I asked you what are the total number of substances produced, different substances produced, so that would be how much? That would be how many? That would be 7, right? Because 6 hydrogens can be substituted, so 6 different organic substances and 1 hydrogen chloride. So in total 7 different substances could form. And if they would just ask you how many inorganic substances would form, only 1, which is hydrogen chloride. If they would ask you how many organic substances would form, only 6, right? So 2 is also correct and 3 is also correct. Therefore 2 and 3 and 4, that option is C right here, right? This particular MCQ says, which statement about fuels is correct? Coal and ethanol are examples of non-renewable energy resources. Sir, ethanol is not an example of non-renewable energy resources. Why? Because obviously ethanol can also be made from glucose, from the fermentation of glucose, and glucose is a renewable source, right? So coal is non-renewable, but glucose is renewable. Hydrogen and oxygen can be reacted to produce an electric current. Absolutely. That is what happens in the hydrogen oxygen fuel cells. So B is correct. Large amounts of energy are taken in by a fuel when it burns. Man, this is so funny. You need to understand that the reason why they are called fuels is because they give out energy to you guys, right? So large amounts of energy are given out in the form of heat. That's why when a fuel is burning, you feel hot. Why? Because it's an overall exothermic reaction. Heat energy is being released to the surroundings, and if you are surrounding, everything around it is the surrounding. That's why we all are getting hot, right? So C is incorrect. Radioactive isotopes are not in your course. And radioactive isotopes are not burnt to produce heat, dude. No. Radioactive isotopes like uranium वगैरह, वो अपनी radioactivity से जो है chain reactions करते हैं. You learn more about this in physics now. It's no longer in your chemistry course. Water is added to anhydrous copper sulfate. Think about it. You have copper sulfate. Anhydrous copper sulfate is white. Done. And if you add water to it, it bonds with 5 water molecules. It's a reversible reaction. So what's going to happen is you're going to get a hydrated salt of copper sulfate, right? And these H2O molecules are basically going to be called the water of crystallization. And it says, and obviously hydrated copper sulfate is blue. So you're going to go from white to blue, not blue to white. And therefore, you need to understand that it says the copper sulfate turns white. No, it turns blue. The copper sulfate turns white. No, it turns blue. So you have to eliminate C and D off, right? Now, if you check this out, he's saying the solution gets colder or the solution gets hotter. Well, I've already told you that, if it's an exothermic or an endothermic reaction, but if you do not remember it, God forbid if you do not remember it, you could use your common sense and think about it like this. Here, if you check what is the difference from left to right hand side, 5 H2O molecules are literally just being bonded to copper sulfate. I'm not seeing any bonds being broken, right? So you have copper sulfate and 5 H2O molecules are directly bonded to it. You can only use this logic or this trick here. You cannot use it anywhere else. You can use it for copper sulfate or cobalt chloride. So think about it. Bond formation has taken place from left to right, and bond formation is what? It's exo or endo? Sir, bond formation is exo, therefore the forward should be exo, because what I am seeing is only these H2O molecules being bonded here. Bond formation is exo, and therefore the reverse should be endo. So that's just a trick for this particular question, and you could use it for cobalt chloride as well. Done? So he's saying the copper will the solution get hotter or colder? We know that in an exothermic reaction, everything gets hot. So the solution is going to get hotter. The surroundings get hot. Remember, the solution is your surrounding. We talk about, the teachers also teach the system, right? but you can never see the system. Some students might think, sir, but in exothermic heat energy is released to the surroundings, but sir, the system's energy will decrease. Sir, you cannot see the system, you cannot observe the system. So anything that you're noticing getting hotter or colder is the surrounding. Remember that. Fun fact, you cannot see the system. Done? So B is the correct option. Okay, so this particular MCQ says which ion forms a precipitate that dissolves in excess with both aqueous ammonia and with aqueous sodium hydroxide. So there's no concept here. It's simply your memory about the tests for the cations, right? So I'm gonna just write it here. This is, sodium hydroxide being added, and then that's the excess sodium hydroxide. Then you have aqueous ammonia, and then you have excess aqueous ammonia. And for calcium 2+ ions, we know that in sodium hydroxide it gives you a white precipitate, and then in excess it's insoluble. Done. And in ammonia, no precipitate or a slight precipitate, whatnot, right? So you could check your ATP table for this. Copper 2+ ions, so because it's insoluble, it's saying it dissolves in excess with both ammonia and with aqueous sodium hydroxide, which is not the case for the calcium 2+ ion. For copper 2+ ion, we know in sodium hydroxide it gives you a blue precipitate, but in excess it remains insoluble. Again, it gives you a light blue precipitate. In excess, it's going to dissolve to give you a deep blue solution. So here it is dissolving, but here it's insoluble. So B is also wrong. If we check iron 3+ out, iron 3+ is insoluble here as well as here. So insoluble, insoluble. It's going to give you a red brown PPT here, insoluble. Red brown PPT here, insoluble. Done. And zinc 2+ ions, well, zinc is the correct option because zinc gives us a white precipitate here, then it dissolves to give you a colorless solution, and then again gives you a white precipitate here, and in excess it's going to dissolve to give you a colorless solution. Done. So zinc 2+ is the correct option, and therefore D is correct. So there was no concept here. You should just remember your solubility rules. 39. An ester C4H8O2 is made by reacting 0.06 moles of ethanol and 0.05 moles of ethanoic acid. Oh, you dumbo, what you need to understand is that they're in 1:1, which means that for every 1 mole of ethanoic acid, for every 1 mole of acid, you need 1 mole of alcohol, right? So which means that they must be in equal amount if you're making an ester. But he is adding 0.06 moles of ethanol and you only have 0.05 moles of ethanoic acid. So how many moles of ethanol would we need for these many moles of acid? Obviously, if they're 1:1, which means they need equal amount of moles. So if you have 0.05 moles of ethanoic acid, how many moles of ethanol would you need? Obviously 0.05. So ethanol is in excess by 0.01. Why did I need to know this? Because I need to perform my calculations with the limiting reactant. So this particular MCQ is very beautiful because he's mixing two concepts together. He's mixing the concept of limiting reactant with the concept of percentage yield, right? So now what I have to do is, and he's saying practically what happened was in the factory when he did this, 0.0375 moles of ester were being made. Now what I have to do is I have to calculate that from 0.05 moles of ethanoic acid, how many moles of ester would be made theoretically, and then I would be able to calculate the percentage yield. Done. So let's do that. Just give me a sec. थका हुआ हूँ, साथ साथ कॉफी पी रहा हूँ. Okay. So, अच्छा क्या करने? Okay, first let's also check out the MR. So if we are low on time, we're going to calculate the MR of the ester, and once we have the MR of the ester, so we're going to have a 50% chance of getting the option correct. But let's do it step by step. So let's calculate the MR of the ester. The ester is C4H8O2, right? So calculated police C4. So you have 4 carbons, so 12 times 4 plus you have hydrogens, AR is 1, and you have 8 hydrogens, so times it by 8. Oxygen is 16 and times it by 2 because you have 2 oxygens. If you multiply all of them, 24 plus 8 plus 16 times 2, 88, and gives me 88, and therefore A and B are wrong. Now let's calculate the percentage yield. Now how do I calculate the percentage yield? I'm going to take these moles of ethanoic acid and I'm going to calculate that from these many moles of ethanoic acid, how many moles of ester can I actually get? So it's pretty easy. If you have 0.05 moles of acid, you would know that let's suppose I don't know how much ester would be made. So that's the acid. and that's the ester. But I know that for every 1 mole of acid, how many esters are you going to end up with? I'm going to end up with 1 mole of ester, right? So for every 1 mole of acid, I end up with 1 mole of ester. So if I have 0.05 moles of this acid, how many moles of esters would I get? Obviously 0.05, pretty easy. And you don't have to do so many calculations. It's pretty easy. Even if you look at it, 1 mole of, it's all 1:1, which means 1 mole of acid would give you 1 mole, so it's the same. So if you have 0.05 moles of ethanoic acid, 0.045 moles of ester would form. But here he's saying only these many moles would form. So theoretically speaking, if there were no losses, you would get 100% yield, and that would be 0.05 moles of ester. But here, because of certain losses or blah blah blah, you're getting 0.0375 moles for some reason. So what is the percentage yield? That's X%. I don't know. So cross multiply 0.0375 into 100 divided by 0.05. 75%. So D is the correct option, C is wrong. Remember, I'm going too slow on this. And the reason for that is I'm solving this particular paper for the dumbest of students. Sorry to say, matlab, how do I put it in a good way? For students who have not learned it conceptually. So I'm trying to break it down for them. Those of you who are quick at it, you guys can do it on your own and just look at the video solution later. Okay. Now, this particular MCQ says, the diagram shows the changes of state shown between a solid, liquid, and gas. In which statement is energy being given out? So he's saying in which particular state change is exothermic. In exothermic, energy is given out, and in endothermic, energy is taken in. Remember, pretty easy. If you go from a solid to a liquid, do you have to provide it energy? Or does it provide energy to the surroundings? Obviously, you have to heat up the solid, you have to give it energy to overcome the intermolecular force of attraction that holds the solid in place and blah, blah, blah. So you are providing it energy. So it should be overall endothermic. The solid is taking in the heat energy from the energy source that you are using, right? So it's taking in. So remember, solid to liquid is not exo, it's endo. Liquid to gas, the liquid particles take in the heat energy to overcome the intermolecular forces of attraction, to completely overcome them and, escape into the air and all of that good stuff. So it's taking in heat energy, therefore it's endo, okay? And therefore the opposite should be exo. The opposite should be exo. Why is it exo? Well, because when you cool a gas has more energy than a liquid, right? The gas particles. So if you cool them down, what effectively happens is that they lose that extra energy to the surroundings, and therefore they move slower and closer together, therefore forming a liquid. And when you put the liquid in a freezer, what happens is, why does it make a solid? Because liquids have more energy than solids. So what happens is that the liquids start to lose their energy because you're cooling it, so they lose their energy to the surroundings, to the freezer effectively, and the particles move slower, closer together, and they are then tightly packed, and the intermolecular forces of attraction are strengthened, right? So that's exo, because the extra energy of that liquid is given out, and therefore it converts into a solid. So 4 and 3 are the ones in which heat energy is being given out, and 1 and 2 are endo, it's taken in. Okay, so you have electrode 1, electrode 2, and this says, in electrolysis diagram, oxidation is occurring at electrode 1 and reduction is occurring at electrode 2, which means that electrode 1 is the anode and electrode 2 is the cathode. And so that's the cathode and that's the anode, which means that's the positive electrode and that's the negative electrode. Now, it says which row shows the direction of movement of electrons in the external circuit and of the positive ions in the electrolyte. Think about it. Where would the positive ions go? Would the positive ions be attracted towards the electrode 2 or would it be attracted towards the electrode 1? Pretty easy, guys. Come on. Because in our physics we've learned that unlike charges they attract and like charges they repel. So the unlike charges are going to attract together. So the positive ions are going to go towards the electrode 2. So their direction is going to be from electrode 1 to electrode 2. Therefore, where are the positive ions? So positive ions in the electrolyte go from 1 to 2, not 2 from 2 to 1, right? So this is wrong and that's wrong. So therefore, B and D are automatically wrong. Now, direction of movement of electrons in the external circuit. So what's basically happening? Your negative ions, let's suppose this is a negative ion, is going to go here and it's going to lose the electrons to this particular electrode. So the electrons are going to be lost here and oxidation is going to take place. So the electrons are going to move like this. And here they're going to move all the way like so and reach this point, making this electrode negative. And obviously when the positive ions come here, they're going to gain these electrons. So the negative ions, they lose the electrons and the electrons move up right here all the way to this particular point, and then they are gained here by the positive electrode. So it's 1 to 2, right? So the movement of electron is not 2 to 1, it's 1 to 2, therefore it's not 2 to 1, therefore A is the correct option. Redo. Copper 2 nitrate and zinc carbonate are heated strongly. Well, obviously whenever you have a metal carbonate, it decomposes to give you a metal oxide and carbon dioxide. And here what happens is whenever you have a metal nitrate, it decomposes to give you the metal oxide, oxygen and nitrogen dioxide, right? And this particular decomposition reaction is no longer in your course. So it says which row identifies the gases produced. Obviously for copper 2 nitrate, it's going to give you the oxygen gas and the nitrogen dioxide. So C and D are wrong. So the gases should be oxygen and nitrogen dioxide. So therefore you have to select between A and B. And for zinc carbonate, we know carbon dioxide is the only gas that's being produced. No oxygen is being produced. No oxygen is being produced. So B is wrong. A is the correct option. Iron from the blast furnace can be converted to steel. Which statements? Again, this particular bit is no longer in your course of how the blast furnace is used to convert iron to steel. But what happens is that steel is obviously, we know that it's an alloy, which is a mixture of a metal with other elements or other different elements. And in this case, you have iron and carbon, right? And in the blast furnace, we get mild steel, right? So it's not a high carbon steel or a low carbon steel. And mild steel, or what does all of this crappy stuff mean? It's no longer in your course, but you know that, high carbon steel, what would that mean? High carbon, more percentage of carbon. Low carbon steel, less percentage of carbon. Mild steel, almost equal percentages, right? So now it says steel contains more carbon than iron. No, if it contained more carbon than iron, then it wouldn't be mild steel, then it would be high carbon steel, right? So one is wrong. Steel is produced by blowing oxygen through the iron. Yes, that's true. How does this happen? No longer in your course. Calcium oxide is added to molten iron to remove basic oxide. Calcium oxide is added to molten iron to remove basic oxides. No, to remove acidic oxides, sir. Calcium oxide is added, absolutely, but it is a basic oxide. How can a basic oxide react with a basic oxide? It is added to remove the silicon dioxide molecules, which is effectively sand, right, and form calcium silicate, which is slag. Done. So not to remove basic oxides, but to remove acidic oxides. Therefore D is the correct option. Moving on, it says ethene reacts with water under suitable conditions. It's a hydration reaction, addition reaction, and we know the suitable conditions are what? A catalyst, which is an acid. In our case, we use acidified phosphoric acid. We use a temperature of 300 degrees Celsius and an atmospheric pressure of 70 atmospheres. Now it says the product of this reaction has an MR of 46. Let's check this out. So you go from ethene to ethanol, and what's the general formula, the molecular formula of ethanol? Well, we say CN H2N plus 1. So if you have 2 carbons in ethanol, hydrogen should be twice the number of that plus 1, which is 5, and then OH. Can we calculate the MR? Let's calculate. So carbon is 12, times it by 2, you have 6 hydrogens in total, 5 here and 1 here. So hydrogen is 6, and we know each hydrogen has an AR of 1, and oxygen is 16. So we add 16 right here, and you only have 1 oxygen. So if we times this, 12 times 2 plus 6 plus 16, that's 46. And yes, A is the correct option. But let's check why B, C, D are wrong. The reaction produces 2 different products. Oh, you dumbo, it's an addition reaction. Addition reactions don't produce 2 different products. Addition reaction may. It is an addition reaction. Addition reaction means that there is only one product being formed, right? The reaction occurs when ethene gas is bubbled into cold water. Cold water in science means H2O liquid, whereas we know that we don't use H2O liquid, we use H2O gas, we use steam, hot water. Done. The reaction is a redox reaction. It's not a redox reaction. There is no change in oxidation states, right? So you could check it out, you could solve it, you could check the oxidation states out, but it is not a redox reaction. And I can't be bothered to solve it for, just to show you why it's not a redox reaction, but you could write the equation out. So it's C2H4 plus H2O gives me, C2H5OH, and you could calculate the oxidation state of carbon here. It's gonna, hydrogen we know it's +1, hydrogen is +1, oxygen is -2, hydrogen will be +1, oxygen will be -2, and the carbon's oxidation state that you're gonna calculate here, who am I kidding? Let's calculate it. So +1, 4, that's gonna be, I'm gonna do it directly, okay? So this is +1 times it by 4, goes on the right hand side, and it's gonna give you -2 here. And it's +6, -2, goes on the right hand side, again -2 here, right? So it's gonna be the same on both sides. In both cases, it's gonna be -2. You can calculate it on your own. But that's pretty much it. We'll solve more MCQs. I'll make another video solution by tonight or maybe by tomorrow, because too tired, man. Seriously, it's what, 3 a.m. in the morning, and I'll upload this in the morning because I'm just gonna go to sleep. Okay, bye bye guys, ciao, Allah Hafiz.